In this lesson we're going to look at the missing category method, which is sometimes used for missing values in categorical or factor variables. So the method essentially consists of replacing the missing values in the variable with a new missing category. And it seems like quite a nice solution for missing values in a categorical or factor variable. Unfortunately, in general, the missing category method results in biased estimates of coefficients in regression methods. And I'm going to try and explain why that bias occurs visually using a simulated example. So the following plot shows some simulated full data on an outcome y, a covariate which is continuous x, and a confounder which here is sex. So sex is a confounder here because the distribution of x is quite different between the males and the females. So the females have got higher values of x than the males do, and sex has got an influence on y, conditional on x. So if we look among people with the same value of x, the males have got higher values of y than the females. So if we fit a regression model for y with x as a covariate and we adjust for sex, we look at the relationship between x and y among men and among women, and if we don't include an interaction, the linear model essentially will be taking an average of the slope that it sees among the men and the slope that it sees among the women and pooling those according to the relative numbers of men and women in the sample. So we can see here that in the full data there's a positive association between y and x, conditional or adjusted for sex. Okay, so to see what would happen with the missing category method, we're going to make some values of sex missing and then make a new missing category. So I've made 25% of the sex variable missing completely at random and then created a new missing category. And what's shown in the plot here is the same as before, except now for 25% of the individuals their sex is missing, they're in the missing category. These are the individuals now marked in blue, and the blue line is the linear regression fitted just for the relationship between y and x to those with sex missing. The pink line is now the regression line for y on x among those who are male and had their sex observed, and similarly the green line for those who are female and had their sex observed. So what we can now see is that among those with sex missing, we've got some who are men and some who are women, and so the missing category now consists of a mixture of men and women. And this blue line, which is the linear regression fitted just to those with missing sex, so the missing category, we can see that we've actually got a negative slope for the relationship between y and x in the missing category, and that's because of this strong confounding that there is, strong confounding effect of sex. And in the missing category, we don't know what the sex is of the individuals. We've lumped together some men and some women. And so the estimate for the relationship between y and x in this missing category is a biased estimate of the relationship between y and x after adjusted for sex. Now, how would this translate into the actual coefficient estimates of a regression model for y? Well, if we fit a regression model for y with x as a covariate and the new sex variable as a covariate with this missing category, essentially what happens is the linear model estimates the relationship between y and x in the men when the male sex is observed, similarly among the women, and then similarly among the missing category. And then if we don't include an interaction between x and sex, so we assume that the relationship between x and y is the same across these three categories, the coefficient of x that we obtain is a weighted average of the slopes estimated in these three different groups. And so the impact of this negative slope in the missing category is going to be that it drags the coefficient of x downwards away from the correct value, which is actually 1 here. So this slide just shows us the actual results of those linear model fits. The top table is the regression of y on x and sex in the full data before any values were made missing, and we can see here that the coefficient of x is something close to 1 after adjusting for sex. And then the table at the bottom shows the corresponding results after using the missing category method. And we can see that the coefficient of x is now far reduced from 1, it's actually quite close to 0. And so this is the bias effects of using the missing category method in the case of a reasonably strong confounder.